In the last video, we saw how we can use aggregate functions to perform tasks on a particular table by using sum, count, max, min, average. And today, let's think of this. Let's say I have a table called vacation, as you can see, and I have names of certain people, the places they went to, and how much it cost them. If I want to, let's say, view this information summarized just based on the total cost that a particular place had, how would I do that? Or let's say I want to see it in a particular ascending or a descending value. It might be tricky to do it just based off what we know as of now. So instead, let me propose to you today that we use something called the group by and the order by. So how does this work? Well, I think based off the name, we can say that group by basically groups records having similar values, right? So let's think, let's say I want to group my place based on the cost, right? So let's write that down and see how that works. So let's say I want to see all the places and the total cost that a particular place has associated with it. So I can write that as, first, since we want to select that, we'll write select. What do we want to select? The place. So select place, comma, the sum of the cost, the total cost associated with it. So select place, comma, sum cost, and we want to group it by the place. So I'll write select place, comma, sum of cost from my vacation table, from vacation, and then group by place. So let's break that down. What exactly did I do here? So I said select the place and the total cost associated with that place from my table called vacation, and then group it by the place. So when the computer executes this, what would be the output? So as we have been doing till now, the first thing that you would want to do is just write down the heading name. So the heading name first is place, and the second heading name is the sum of the cost. Separate the headings. And now let's try to group this. So let's look at the first city we have there, which is Delhi. So I can see there are three different entries for the city Delhi. The first has price 2000, then 3000, and then 5000. So what happens is the computer will go here and it will see the place. Acha, so Delhi is the first place. So Delhi, and उसका total cost कितना associated है? So यहाँ पर जाएगा 2000 plus 3000 plus 5000. So it will come out to be 9000. Oh sorry, 10,000, दो है ऊपर. So it looked there. So Delhi first has a cost 2000 plus 3000 plus 5000, 6, 7, 8000, 9000, and then 10,000. Then it will move on to the second city, which is Mumbai. Mumbai has a total cost associated of 1000 plus 4000, which is 5000. So this is how the group by function works. But let's say अब मुझे देखना है केवल वो cities जिनका cost, like total cost जो है, let's say 7000 से कम है, below 7000. So in previous videos we used a clause called where, right? We used to identify particular rows based on where. But here I'm going to introduce a new word called having. So what's the difference between where and having? Having and where में यही difference है कि having is used for groups, whereas where is used on rows, individual rows. So coming back to my original condition, if I want to see all the rows which have a value less than 7,000 in the total cost associated with them, I'm going to write select place comma sum of cost from vacation group by place having sum of cost less than 7,000. So now it will come here and it will change the output. Since we have two groups, Delhi 10,000 and Mumbai 5,000, that means the only option which is less than 7,000 over here is Mumbai. So in the output, we will not see Delhi, instead we'll only see Mumbai 5,000. Okay, so this is how we grouped it. But let's say that maybe I want to see the places and the total cost they had, but in a descending order or an ascending order. So just to add in some more output combinations, let me change the names of a couple of cities. So let me add in Raipur and Nagpur. Okay, so remember, this was how we grouped it. But let's say that I also want to change the order. So for this we use the order by clause. Now the way we use the order by clause is just by writing order by. So let's say I want to select everything in this table and then set it in, let's say, descending order. So the way I'll do that is by writing select star from vacation and we are trying to order this based on the cost. So I'll write select star from vacation order by cost, and since I'm trying to set this in descending order, I'll write DESC semicolon. So the output would be the entire table. So let's write it: name, place, cost. So the most expensive one is Raipur. So we have Meena, Raipur 5,000. Then we have Rohan, Nagpur 4,000. So this will continue and it will print out all the values that we have inside in the descending order of the cost column. Okay, so now that's also done. But let's say now I want it in ascending order. How would I do it in ascending order? Well, the good news for you is for ascending, you can just leave it as order by cost. So by default, the order by function orders everything in ascending order. ठीक है. So we did grouping, ordering, selecting, and in the previous videos, inserting, updating, altering. But let's say I want to delete a particular row. Let's say I made a mistake while entering and I want to just delete a particular row from my table. How would I do that? The simple way, and like I always say, computer science is simple and straightforward. Okay? So the way I would do that is by using delete. Right? You want to delete something, just use delete. So if I wanted to delete a particular record, let's say I want to delete Asha Delhi 2000. So the way I would do that is I would write delete from, where do we want to delete from? We want to delete from vacation table. So delete from vacation, delete from vacation. What do I want to delete from vacation? I want to delete Asha Delhi 2000. Now I would just like to remind you of what we discussed earlier. Normally in each table you would have a particular column that uniquely identifies a row in this table. Now in this case, since it's a very small table, let's just say that it is my cost, because that's not repeated anywhere over here. Normally you should have something as an ID number or something, but in this case I can say that it is depending on the cost. So I'll write delete from vacation where cost is equal to 2000. So the computer will go here, it will see where is the cost equal to 2000. So it's equal to 2000 for Asha's row. So it will just delete that entire row from the table. Okay. But let's say you made a mistake while entering all the data in the table. Let's say you want to delete the entire data in that table. So what you would do then is you will just write delete from vacation or the table name. So delete from table name, semicolon. So this will clear out the entire data present in the table, but the table still exists. Okay, important. Delete from table name will just clear the table. If you want to completely remove the table from the database, you'll write drop table name. So in this case it would be drop table, and instead of table name you will just write vacation. This would completely delete that table. Okay, so now we are nearing the end of this topic. So let's go back to the first video that we had on this topic and think about some of the keys that I had introduced: the primary key, the alternate key, the candidate key, the foreign key. This is where it comes into play. So let me introduce to you constraints. When I say constraints, what comes to your mind first? Think about it. When I say constraints, the first thing that comes to your mind is probably restrictions, some kind of rule, right? Something that restricts you from doing something. Similarly, constraints over here are conditions or checks on a field or multiple fields which restrict data going in them. For simplicity, you can just think of constraints as checks or conditions on a field or a group of fields. I mean, from that it is inferred that they restrict the data going in them. Okay, so what exactly are the constraints we are going to talk about? The constraints we are going to talk about are, first, not null, unique, primary key, default, check and foreign key. So the good news is that they're simple, they're straightforward, and based on their name you can assume what they do. So when I say not null, I think you can understand it means that okay, whatever it is, it cannot be null, right? Perfect, very good. So if I wanted to, let's say, create a table and I wanted to have, let's say, 3 columns, or let's take 5 columns so that we can use the same example for all of these constraints. Let's say I wanted to have an ID number, so student ID number for that table, for a table called student. So student ID number, student name, student age, student average, and student grade. So let's say these are the 5 columns that I want to have. So if I wanted to say that, you know, that when you are entering the information of a new student, you cannot have the name as null or blank. So I can do that by writing, when I'm creating the table. So remember, how do we create a table? We write create table and then the table name which I want is student. So create table student, create table student, open brackets, and the first column I have is SID, SID, which is an integer. So SID int comma S name, which I want to say is a varchar of length 30, but it cannot be null. So the way I would do that is I would simply write S name varchar not null, comma S age integer, so on and so forth. Okay, so that would mean that nothing that goes in my S name column can be a null value. What do I mean by that? What exactly is going to happen? So let's say I try to insert some data. So let me write insert into student values, and for the ID let's say I give 20, for the name I give null, for the age I give 30, for the average I give 20, and for the grade I give D. This will lead to an error because I am trying to insert a null value into that particular column. Let's just to make it more clear, let's say I only try to insert the ID and the name. So let's say I say insert into students and my columns are SID comma S name. Remember, when we are inserting data, we can select which columns to insert data into. So let's say I try to insert it only into my SID and S name column. In this case, if I write 20 only, this would also lead to an error because I'm not passing any values for a column that is not null. Okay, so this is how my not null works. What about unique? When I say unique, the first thing that comes to your mind probably is different, something that's unique, distinguishable, right? So the unique constraint works by ensuring that no 2 rows have the same value in a particular column. Okay, so if I was to say, is the cost column here unique? That's true, no 2 costs are the same. But is my place column unique? Well, it's not unique because I have Delhi repeating twice. If I would have made my place column unique, then the second value of Delhi would not have been accepted when I was trying to enter it. So let's see how we can do that. Let's say that I want to enter a value which is unique. Let's say I want my student ID to be unique. Okay, so the way I can do that is by saying create table student SID. What's the type? It's of integer type, and now I can say SID integer unique, and then I can continue comma sname, so on and so forth. So what this does is it ensures that no two columns can have the same value, but accepts null. So what that means is, if I had, instead of this Delhi, I had, let's say, null, this is valid. Unique distinguishes and makes sure that no two values in the column are the same, but it will also distinguish that based on null. If one value is null and the others are all different, that's valid. Unique accepts that. Okay, so these were two of the words that we did not really touch upon in the first video. Now is where the real fun of SQL starts. Let's say I want to make a particular column my primary key, right? Let's say I want to make my student ID a primary key. How would I do that? I would do that in the same way. So I'll say create table student, and now I'll say SID is my primary key. So I'll write SID, it's an integer, so int, and this is where I'll write primary key, comma, then I continue sname varchar 30, and let's say I want it not null, so not null, comma, so on and so forth. Okay, so what I just did essentially is I made my student ID column as a primary key, which means that it has to have a value and it cannot have the same value appearing in it twice or more. You might also see people write SID int not null primary key. Yes, so you can combine multiple constraints together. That is perfectly valid. SQL allows you to do that, but it's your preference when you're declaring a primary key, if you wish to write not null primary key or simply primary key. SQL accepts both. If you want it for clarity purpose, you can write not null primary key. Okay, now let's say that I want to have a particular default value. Let's say that in my average, if the user does not enter a particular average, let's say the average assigned to the student is 0. Unfortunate, but that's how it is. So let's say I want to assign a default value to 0. This is where the default constraint comes in. So the default constraint assigns a default value to that particular column if the user fails to enter something. So I can do that by now writing my third column. Oh, we have a different column SH, so let me just add that here now for now. So SH int, comma, now my average. So let me write SAVG float, and now I'll write default, and then I want to assign 0, so I'll write default 0, comma, so on. Okay, so let's break down what happened here. When you assign a default value, the syntax is default and then the value followed by whatever other things come after it. If it's a numeric type data type, then you can just write default 0 or default 80, doesn't matter, whatever it is. But if it's a string type, then you would write default quotation, whatever the string x, y, z is, close quotation, comma, and then whatever comes after it, or maybe it closes. Okay, so very important point. If the default value is a string, enclose it in quotation marks. If the default value is numeric, just remove the quotation marks. Okay, so that's how the default constraint also works. Now let's say I want to just check how a particular that a particular condition is satisfied before the data is entered. Let's say I want to ensure that the age of all my students being entered is greater than 0, or let's say greater than 10. So the way I would do that is I would come back here to my age column declaration and see sAge int. Okay, that's valid. And now I'll write check. So this is going to check a particular condition over here. So check, open brackets, age, or sAge over here, sAge greater than 10, close quotation, close brackets, comma, whatever comes after it. So what happens here in that particular condition is it will check that the age being entered is greater than 10. If not, it is going to reject that input. So now we have talked about the unique, the not null, the primary key, the check, the default, and that leaves us with the foreign key. Now before we move on to the foreign key, let's complete this entry and let's just try out a few insertions of values to make sure we are all clear and on the same page about the concept. So after we have average, let's say that I have my grade left, so s grade varchar 1 close brackets semicolon. So now let me try to insert a particular value. Let's say I want to insert an answer for all this. So let's write it out together. So insert into student values. So the first column is the student ID. Let's say I enter 13, comma, the student's name. Let's say I enter Rahul. Remember, Rahul will be in quotations because it's a string type. So Rahul followed by the age. So let's say 30. Then I have my average. So let's say his average is 53.2, comma, his grade is D. Close the brackets, insert a semicolon. Okay. Here, let's say that I change the values now. For my SID, if I try entering 13 again and I change all the remaining values, it's going to still raise an error because student ID is a primary key. It cannot have the same value appearing in it twice. Now, if I was to change that into an 18 and have my name as null, this would still lead to an error because I have told that my name cannot be null. So this is also not acceptable. Okay. If my age over here was 3, it would still reject the input because I have kept that the condition that being checked for, that age is greater than 10, has to be true. Now if I was to maybe not provide the input for the average, it would by default assign a 0 over here. So that's taken care of. And lastly, the grade does not have any conditions on it, so that's totally okay. Okay. Now let's move on to the last constraint that we have called foreign key. let's say that I have a school database where I divide it into department and student table. So I have a table called department which has department ID and department name, and I have a table called student which has the student ID, student name and the department ID. So the relation here is that every student belongs to a particular department and both of them have a department ID assigned to them. So the way that this would work is, let's say this is my parent table and this is my child table, which is referencing values from the parent table. So let's create my parent table first. So this is very straightforward. You just write create table DEPT for department, create table department, open quotations, the first one, open bracket, sorry. The first one is department ID, which is an integer, comma, my department name, which is a varchar of, let's say, 30. So now I have made this table. Now the student table is half easy, half tricky. Let's do the easy part first. So we know that student ID, student name are not related to that. So that's completely fair. Let's write that down. So create table student, create table student SID, which is an integer, comma, S name, which is a varchar of 50, let's say, and then I want to create my department ID as well. So I'll write comma, let me just write that here so it's easy to read. So rewriting that quickly, create table student SID integer S name varchar 30, and now this is where it gets interesting, comma. Now I know that I want to access the department ID as well, so I'll write department ID, which is also an integer, So now I've created 3 columns of my student table, but I want to access the department ID values from my department table. So that means the department ID in the student table is a foreign key. Remember, what's the definition for a foreign key? A foreign key is a column in one table that refers to the primary key of a different table. So in my declaration of the student table, I'll write, so I've written SID int, which is the student ID, S name varchar 30, which is the student name, department ID int. Now I'm going to mention explicitly that foreign key, what's the name of the foreign key? Department ID. So DEPT ID refers to references this table's department ID. So DEPT depth ID. That's it. Let's break this down. Let's break this down further. What I just did was said create a table student. Done. First column SID integer, okay. S name varchar 30, okay. Department ID integer, okay. And now foreign key department ID. So this is the foreign key in my students table. References refers to the department table, the department tables, department ID. This. So this is a syntax you're going to have to remember. Once you once you write all the constraints down, you are going to write at the end foreign key, the name of the foreign key, references, and the name of the table to which it references, and then in brackets the column in that parent table to which it refers to. Okay, so let's say that I have in my department table, let's say department 101, 102, 103. So let's say department name 101 is chemistry, 102 is math, 103 is art. Alright, and now let's say I'm trying to insert values into my student table. So I'm going to write insert into student values, and let's say I want my student ID to be 20, my name of the student to be Rahul, and the department ID is 101. Perfectly valid, works out, and I can do this as whatever student ID, name, and any of these three department numbers which are present. If, however, I was to write 107 over here, what's going to happen is the computer will come here, it will say okay 20, okay Rahul, 107, that doesn't look right because I do not see any 107 value in my department ID table. So that will lead to an error. So these are the constraints, and this is the beginning of the conclusion for this chapter.